How about now? Ooh, I can hear myself. Can you guys hear me? Let me know in the chat. Still nothing? Well, that's poopy. Still no sound? All right, I'm going to log off. I'm going to log back on. So if you guys, oh, fantastic. Somebody said yes. Yay. Thank you, me, and thank you, Danielle, at the library. It's appreciated. This new headset connects when it wants to. It's also connected to a phone. So sometimes it connects to my phone when it says it connected. So I am sorry. I apologize. I'm more upset that I just wasted 5 minutes of your time talking to myself. And it happens. Sorry. If you're just joining me, my name is Chris Dorman. I work with the Maine State Library. I am the STEM librarian. And today we are going to continue our conversations about light. And we're going to talk about invisible light. Now, I know that's an interesting topic because right now you guys can see me. I'm in my basement, I'm in my little lab lair. And the reason you can see me is because I'm sitting under the light. You can see everything behind me because the light is bouncing off it, going into our eyes. Our eyes are doing the thing with the cones and the rods. We'll talk about that later, I promise, so that we can visually comprehend. Now, last week when we talked about visible light, I said, I remember that we talked about the spectrum and how there are wavelengths, and there are certain wavelengths that our eyes can see and that other animals can see. Now, as humans, there's a very, very tiny window of the actual light that we can see. But as humans, we've also learned how to use the light we can't see. And I know you guys saw me hold this up, but you couldn't hear me talking. This is an infrared heat thermometer that I stole from my husband, who is a cook. All right. I am not actually using this as a thermometer, although my cardboard box is currently reading at a balmy 64 degrees in the basement. Um, what I'm going to do is there's also a laser pointer on here. Now, lasers are pretty cool. We're not going to get into the in-depth laser science, but I want you guys to know that you can't see that laser, right? I know it's there, and I know it's there because if you look on my hand, you can see that little teeny red dot. And the reason my lighting is so poor is because I'm gonna actually shut off the light to prove this to you guys. So again, you can see the laser reflecting off something, just like when we see light, we see, oh, excuse me, you see light reflecting and coming back into our eyes. And that's how I know that there's orange and purple and green. Again, we're going to talk about colors and light later. Um, but I want you guys to know about some forms of light that we as humans use all the time that we can't see. Anybody broken a bone? I've broken two this year. It's been pretty rough. I need to pay attention to where I put my feet. Anybody had an x-ray? X-rays are forms of light, but we can't see them. There's another one, uh, ultraviolet light. Now, you guys might have heard this a lot because ultraviolet is very strong. It's the reason we get sunburns, comes from the sun. It also kills a lot of bacteria. It's used in sanitizing. It's actually used in a lot of high-tech water treatment. They actually run the water underneath a little bank of UV lights, and that basically kills all the creepy crawlies so that it's safe for us to drink. So that's another light that we can't see really, but we know it's there. We've made discoveries. The one that we're really going to focus on, because obviously I'm in the basement, so I don't have any sun right now, and I'm a Maine kid, so I try not to go out in the sun because of burn. But I really like IR. Now, IR is around us, and I don't know if you guys know what this is. This is my switch, and I love it. But the technology that the switch uses is the same technology that I told you guys to pick up. Now, this is called IR, and it's infrared. It doesn't hurt you, it doesn't do anything weird, like, but you can't see it. And I'm actually curious Wait, so that's my TV. Now I know this won't work, even though I'm hitting the on and off button to my TV upstairs, because this little teeny light bulb, this little teeny light bulb is going to be blocked by the floorboards of my house. Now, what I want you to do is, you guys see the light, right? And again, this won't hurt you. Do you see the light? So why is it that when I do this, I can look at the screen and I can see that this light is going off? But when I push the same button and I look at it with my eyes, I can't see anything. Any ideas? Because our eyes can't see infrared light, but it controls so many things in our lives. Okay, so it turns our TVs on and off. It's how my Switch knows when I'm playing Mario Kart, because there is an IR sensor right here, and it lets me know if, I want to go into the sand pit, or if I want to shoot a blue shell, that it should go this way or that way. Um, and the other way that we can use it is, we can't see IR. I've mentioned that. It doesn't hurt us, but technology can. Because again, I can't see this, but my computer can. So that means, I don't know if you guys have ever seen these. These come with a Switch. And again, you don't need these. This is just, it was on clearance, but it's a great example of how IR works. So I'm just going to open this up. Just a big cardboard backpack. Come on, open up. Now, inside this, do you guys see? I can move them up and down. Whoops. No, stay open. Goodness. Ugh. All right, here. We'll move stuff around. Sorry, guys. Poorly positioned. Now, inside this, you can see all of these reflective bricks, right? Those are just pieces of tape that I put on. Okay. These are pieces of tape as well. Now, what happens is the switch goes in here in a spot. And whenever my arm or leg moves, this rises. The IR laser, the IR light rather, tracks it, so that when I put on this backpack and I have my little hands and my little feet on, these are my little feet. I put them around my socks. These are my little hands. I just hold on to them. When I push, just kind of like a marionette, like a puppet, the switch knows. And I have a robot on my TV that follows. So if I pick up my legs and I move my arms, I can punch and I can run after things. I think they're still on clearance. So they're, again, if you have a switch, this is not a necessary plug for any system. We're a nerd family, so we have a lot of them. I just happen to know that the Switch uses IR. This is their Carbetto kit, and I think this is the robot one, but I'll put it in the chat later. But anyway, this is invisible light, and that invisible light tracks. So it's in everything from our remotes. Cell phones sometimes use them. Uh, it's it's everywhere, and it's light that we can't see, but we figured out how to use. Now, the reason I said, woo, get this out of the way. The reason I said you guys need a cell phone or a digital camera is because I want you guys to try it. Because, you could just be like, oh, she can see it. She's not telling the truth. What I want you guys to do is take that remote that you have, take that digital camera or that cell phone, and one person should just sit there and be like, I'm going to push this button. I'm not going to let it up. And the other person is just going to have the camera on. Is just going to watch. And I want them to be able to see that when we use our eyes, oops, sorry, that might have been loud. When we use our eyes, we can't see it, but the camera picks up those wavelengths and sees the IR light. And I think that's really, really cool. And it's a really, really interesting and fun thing to play with. A lot of our robotic sensors use IR light. I know that I use Dash and Dot a lot. Little Blue Robots by Wonder Workshop, phenomenal gifts. And they use IR sensors, so they know by bouncing off light from my hand that they'll be like, "Ooh, that light came back," or "No, there's nothing in front of me." But those are probably, well, those are just some examples of light we can't see that we use every day and we don't even realize it. So there's a lot of light. Ultraviolet light comes from the sun. X-rays, a form of light and energy. Obviously, we use that to see if we have any broken bones. I wish I had the picture of me with my broken ankle because it's not a bad one, but it's still pretty cool. Maybe we'll talk about anatomy another day. Maybe we'll make some lungs. If you guys think of themes or projects that you want to do, please put them in the comments. I do look at them after this. I'm always looking for suggestions, and I want to know what you guys want to learn. We are almost out of time. I want you guys to know that next week we're going to talk about light as energy because we see with light and we understand that light, especially white light, is light we can see, but it's made up of many different colors. And like right now, my camera, I don't know if it shows up on the video, but I see it going from warm to cool because the sensors that pick up light in my laptop are having a hard time with this LED and me moving back and forth. Again, it's all about light and sensors. But we're going to talk about light as energy and power. We're going to talk a little bit about solar. We're going to play with some solar lights, and it's going to be amazing. So, as I mentioned before, my name is Chris Dorman. I work for the Maine State Library. I'm the STEM librarian. This has been Science Online. We've talked about invisible lights that we can't see, preferably IR. Probably ruined this remote now. And how it works in telephones, how it works in video game controllers, how it works in my little IR reflective backpack. It's pretty cool because it's science. Let me know what you want to do. Let me know in the chat. And we will see you guys for Light as Energy next week, Wednesday at 3:30. Have a fantastic day, guys. Go outside. It's nice out. It's supposed to snow this week. Bye, guys.